Hi everyone, welcome to lecture 9. My name is Gonzalo. I'm one of the guest lecturers and I'm going to be co-teaching the iOS course next semester. I've, I'm a CS junior. I've been on app dev for 3 semesters on the iOS team. I recently switched to backend, but regardless, I want to become course instructor because I just wanted to share my experience from taking the course and my 3 semesters on app dev. So I'm going to be teaching about SnapKit UI gesture recognizers and debugging today. It seems like a lot, but it's not as daunting as it seems. So just get started with SnapKit. It's a CocoaPod similar to how you guys downloaded Alamo Fire. And basically what it does is it just makes your constraints much better and much easier to read. And there are some nifty tricks that you can also do with SnapKit. So if you take a look here, this is how you're used to making constraints. Here you're setting some views top anchor equal to the view safe area layout guides top anchor, and you're offsetting it by 24. You're doing the same thing with the leading anchor and is offset by 24. And then you're setting the width and the height equal to 30. And if you do this in SnapKit, it looks much nicer and it's actually readable in English. So first you have to do .snap.make constraints, and then you have a closure. And then over here, you can, make can be whatever you want it to be, but if you type in make, you can just read it like an English sentence. So for example, I want to make some views top anchor equal to the view.save area layout guides anchor, and I want to offset it by 24 pixels. Same thing here for the leading anchor. But over here, instead of making it equal to something, we can just set it equal to the super view. While over here, you have to type in view.leading anchor. So it's nice syntactic sugar. And we just offset it by 24 as well. And over here, you can also see that the width and the height are chained together, because over here you see that both the width and the height are the same, but SnapKit has a nice chaining feature where if they're both equal to the same thing, you can just put dot, make dot width, dot height, dot whatever, dot equal to 30. So that's what makes SnapKit nicer. We're also going to be looking at some more advanced features in the demo, such as .snap.remake constraints or .update constraints, but I'll get more into those in the demo itself. As for UI gesture recognizers, there are multiple of these. These are special things you can do that the iOS can track. For example, a UITapGestureRecognizer, which is very similar to how UI buttons work, and provide an example for that. You can pinch, which is just zooming in, zooming out. You can rotate things. You can also swipe, pan, which is just like dragging things around. You can also do a screen edge pan, which is more towards the edge of the screen, and then a long press, which is just holding a button or holding something for a long time. And of these, we're just going to focus on 4 during the demo and make a nice looking app. It's Christmas themed, so Christmas spirit. But we're just going to focus on the UI tap gesture recognizer now, so you can see similarities. First, I'm going to review the UI button. So here we're just instantiating a UI button. We have a function that sets it up. We set its background color to red, and then we just add the target as normal. One special thing I'm doing here though is you can see that normally you just put in the name of the function that you're doing at Objective-C, but here I'm also passing in sender. So this is one nice thing about selectors, that you can actually pass a reference to what is actually sending that action. So that's what I'm doing here. You can just let it autocomplete, but you just have to put in the name of the function and then the parentheses parameter and then the colon. And then dot touch up inside. So as soon as you release your finger, it'll activate this target. And inside of the some other function, all you're doing is you're just toggling the color of the button itself. So this is what a UI button looks like, and a UI tap gesture recognizer is very similar. You'll see that basically nothing has changed except we changed the view to be it's just a regular view. And for the tab gesture recognizer, it's very similar. You have the target and you have the action. That doesn't change from the button. you also have some features of the tap gesture recognizer that these are the default ones, but I just want to put them here to show you that they're very customizable. For example, you can tap them a couple of times. So maybe you can set it to 5 and you'd have to tap it 5 times before it actually runs some other function. You can have it so you have to press the view with 2 fingers or 3 fingers or however many you want. And the only difference is if you go back here, you see that in some other function, we have let button color equal to sender.background color. The difference here is that you'd have to actually get the sender's view, because what's actually sending the request to run the function is the UITapGestureRecognizer, not the UI view. So that's basically it. We'll get into debugging more in the demo itself. But so let me open it up here. So this is actually what the app is going to look like when we're finished. So we can click on, basically, we're just going to put ornaments and presents around, right? Around this Christmas tree. If you click on this candy cane, it switches with ornaments. You have lights, and then you have Gingy from Shrek. And you can also do the same thing with your presents, right? It's just a little rotation. You can't do it with the Christmas tree. So this is just an example of the UI tap recognizer. UI tap gesture recognizer. Then an example of the UI pan gesture recognizer is actually clicking and dragging these around, right? You do this with your finger. And you can also use a UI pinch recognizer. I'll teach you how to do this when we get to that. But you can, this is just simulating 2 fingers on the screen. I can, oh, okay, I just realized that my screen share was paused. So I'm just going to show you here what the app should look like when we're finished with it. So there's 3 elements over here. These would be ornaments, these are presents, and this is just our tree. So if we click on the ornaments, they actually rotate. It goes from a candy cane to some Christmas lights to Gingy from Shrek. And then it just repeats that cycle. Same thing with the presents. It's just 3 different presents. And the Christmas tree, you can't switch it. But this is an example of the UI tap gesture recognizer. You can also drag these around. This is using the UI pan gesture recognizer. You can drag all of these around. Now with the UI pinch gesture recognizer, I will show you how to do this later, but this is simulating 2 fingers on your screen. So what you can do is, if you were to motion to enlarge things, right, you can scale these up, and then you can also scale these 2 to make them bigger or smaller. And one last feature is the UI long press gesture recognizer, which basically what I added was if you click and hold for a bit, you'll actually duplicate one of these. And so you can use these to decorate the tree and whatnot. So yeah, that's basically what's going to look like when we're done with this. So let's actually open up this starter code and then just jump right into it. So if I run this is the starter code, and right here I click on everything, I drag, I pinch, nothing happens, right? So none of that is implemented right now. So we just look at the starter code right now, and over here we see that we have 3 image views. This is the ornament, present, and tree image view, and over here we have set up views, we have set up constraints, these are these functions. Over here, we're just setting up the views as normal. And we're using images from our assets over here. And over here, we just set up the constraints. And these constraints are using the getDimensions function, which we have down here. These are just function subs that we're going to use for our gesture recognizers later. So over here, we get dimensions. All this is it takes in an image view, right? Specifically the ornament or the present image view, because those are the only ones that would switch dimensions, because we're not expecting the tree to change when we tap it. And on the ornament image view, it checks to see which image it is currently, and it's going to return some hard-coded dimensions for that image. So that's all this is really doing. And it does the same thing for the presents as well. So over here, we have NSLayoutConstraints. So the first thing that we're going to do is convert these to SnapKit constraints. But to convert those, we're going to need to import SnapKit. And it should give me an error because we haven't actually made a pod file yet for this project. So just go over this real quick. I can do pod init. And then here we go in my pod file. If I vim into it, I'm just going to go over here, pod SnapKit, and then we'll write that to the file. And if I do a pod install, we should have, yeah, okay, so I've installed it. So I'm gonna close this out because now we don't wanna worry about that. We don't care about this one anymore. We want to use this one, the workspace. So I'll open this one up and now we should be getting SnapKit errors. Let me just test it real quick. Snap, and yes, now we have everything there. I'm just gonna close this out and okay. Great. So to convert these, we'll just do snap.makeConstraints. I'll hit enter and I'll press backspace twice, type in make. And now to convert these, so we see we have a center X anchor, So that's just make.centerX. I want to make that equal to the views.centerX anchor. That's the same thing as just making it equal to the super view. So that one's taken care of. We can do the top anchor now. Make.top, or make.top. That's also equal to the super view. So it's just view.top anchor. And it looks like it's offset by the screen width divided by 3. And the screen width is just getting, it's just UI screen.main.bounce.width. And we can do that by offsetting it by screen width divided by 3. And then our width and our height are both different. So we'll just make the width equal to just copy these. So we'll get rid of this now. And let's just run it to make sure we're on the right track. Okay, looks fine. All right, now we're gonna do the same thing for this one. I see this has a center X. This also has a width and a height. No, this one has a bottom. So I'm just going to copy this because it's pretty similar. And I'm just going to copy the name. This is the present image view. So this stays the same. This is a bottom anchor. So we're going to change this to bottom. Now, this is just the negative of the screen width divided by 3. I can just put a negative here, or SnapKit also allows you to do an inset, which is just implicitly negative instead of offsetting it. Well, this is from the bottom, right? So if I were to offset, it'd go off the screen. So if I want to inset, it actually just applies negative. So it'd go up instead of down for offset. And for the width and the height, I'm just going to copy this. And let's get rid of this over here. Let's rerun. Okay, so this still looks fine. And now we're going to do the true image view. So I'll copy this once more. And copy true image view. So here we don't have a bottom, we have a center Y. So one way of doing this is just typing in center Y dot. This is just the chaining, as I discussed in the PowerPoint or the keynote. And you could just do this. This is fine. Or SnapKit also has just the keyword center, and is basically doing that chaining. And then for the width and the height, we want to switch this to this. Okay, let me get rid of this now. And let's rerun. Okay, great. Everything looks fine. Cool. Okay. So that's just basically SnapKit. We'll go into the more advanced remake constraints and update constraints later. But now that we converted everything, now we can actually start implementing the gesture recognizers. So if we look here, we have swap image. This is the first one that we're going to work on. So this sets the sender's image view to the next image in our hard-coded order upon tap. So this is where we'd click on the candy cane, we'd get the lights, and then we'd get the gingerbread man. So because we're swapping from candy cane to lights, lights to gingerbread man to candy cane again, there's a lot of control flows in that. So we're just going to copy this dimensions function because it already has a nice switch. And we're going to use that for now. We're going to change it to our purposes. So, right, so there's a lot here. So right now, okay, image view will actually be sender. So I'm just going to change this to image view to simplify that. And var, this we're not using it in the dimensions right now. So over here, I think these will go away. Yeah. So now that we're not using these dimensions, what we're doing actually is if my image view is candy cane, I want to switch to the lights. So I'd actually set the image view image to be UI image view lights. And then set this one to be gingerbread. And then we set this next one to be candy cane again. Same thing here. We go from the green present to the orange present. So over here, orange present. We'll change this one to be the white present. And then we'll change this one to be the green present. And then, well, we're not returning anything here. All we need to do in this function is just change the image. Now we have this. What we want to do now is we actually want to attach the gesture recognizer. So to do that, we need to go over here. One important thing that we have to do that I just realized was not in the PowerPoint is in order for any of the gesture recognizers to work, we need to make sure that is user interactable is turned on. So we're going to make sure that all of these are user interactable. Just to start off, we have this. Well, we're not messing with the tree right now. This swap image is only for the ornament and the present image view. So to actually add the gesture recognizer, we want to do ornament image view dot add gesture recognizer. Here we can put the UITapGestureRecognizer, and we're going to set the target to self. We want it to you have to press itself to work, and then we'll set the selector to swap. And this is for instead of sender or image view in our case, because the parameter would be called for when you do it this way. So we want to do the same thing here with the present image view. And yeah, so we can test that and see if that works. So I click here and nothing's actually happening. And so when you get in a situation like this is where you start debugging. And that's actually what I'm going to introduce right now. So what we want to look into is this function, right? So debugging with Xcode, if you've done any debugging before, it's pretty similar. You want to set a breakpoint first. So I'd set a breakpoint just here at this function. So you just have to click here to set a breakpoint. You can swipe to the left to get rid of it, or you can click on it again to temporarily disable it. So if I click here, nothing should happen. But if I were to click again, now it's actually activating. So we know that we're tapping on it and it's actually working because it actually got in here. So here we see this is the breakpoint, and this is the debugging part down here. And so if we click here, this is just going to bring it down. If I click this, this turns gray because this disables all breakpoints. If I were to click here, this is continue program execution. So I'm going to be able to interact with this again. So if I were to click here, if I'm on a breakpoint right now, I'm not going to be able to interact or see anything happen on the app because it's just frozen. These buttons over here, this is step over. So if I were to click here, it's step to the next line of code. And I just stepped over, meaning that I stepped over the entire switch. Let me try that one more time. Let me try a step into. That also didn't work. Sometimes you need to step into, for example, if I were to restart the app and I were to, or actually I need to set a breakpoint right before, because this is when view does load. I'm going to go over here. If I were to step over, or actually, yeah, this actually steps inside. Okay, so that's fine. So let me set a breakpoint over here. This is probably a better example. So for the function, if I were to click step over, it just steps over the entire function. And if I were to click step over again, it'd do the same thing. Now, if I were to click on step into, it actually steps inside of that function. And then I can just keep clicking on step over and I'll keep going. Once I've reached wherever I want to reach, I can just click on step out and it'll take you out of that function. Now you want to be careful when messing around with Xcode because you can get taken here to the disassembler. Whenever you get here, this is just no man's land. You just click this and it takes you away from that. So actually back to the function that was problematic. Right here. Okay, so if I click again, I step over and I step over the entire switch statement. It didn't actually enter it, which means for some reason, the image view that it's detecting is neither an ornament image view or present image view, which doesn't make sense because I am clicking the ornament image view. So that must mean that image view has to be something else or there's some issue. So I'm just going to click on it again. And over here, you also see there is this self variable, which is just going to tell you everything that's inside of the view controller right now. But then there's image view, which we want to actually take a look at. And here you see that it's a UITapGestureRecognizer. So even though we said that this is going to be a UI image view, it passed in as a UITapGestureRecognizer. So the debugging is really useful because you actually get to see what is what. Because over here, I would expect the UI image view to actually be here, but that's not actually the case. So if I were to open this up, you can see the UI gesture recognizer. You see a whole bunch of its properties. Also, like in the keynote, we have to do sender.view to access the view. And you can see that variable over here. It has a underscore because this is a private variable, I believe. But regardless, you can access this. So we want to access the sender.view to actually get access to the image view. So let's fix this over here. This is not actually the image view. This is actually a sender, right? And this is our UITapGestureRecognizer. and now I'm getting a whole bunch of issues. So if I were to do sender.view, sender.view, you'll see it's optional. So one option that we can do is just type in view again. You can have an entire if let image view equal to sender.view and then wrap the entire switch statement inside of brackets, but that's disgusting. So what we're going to do instead is a guardlet, because this looks much nicer and is more appropriate for this case. I'm going to set the image view equal to the unwrapped sender.view. And if this turns out to be, if there's nothing in sender view, then all we have to do is just return. Now it's saying that this is a UI view too. So sender.view is a UI view, but we want a UI image view. UI image view is a subclass of UI view. So what we want to do is we want to downcast it. If you want to force downcast, you need to do an as with an exclamation mark, and then you type in UI image view. And bugs are gone. This, I think you need to put this over here. I should say it's optional or not. Okay. Initializer for conditional binding must have optional type. Right. Yeah. Okay. So the reason you have to put an optional type on the UI image view is because you're setting this UI view, this optional UI view, to an optional UI image view, because you don't know if this has an image view in it or not. So that's why you have to do that. So if we run the app again, if I were to click, oh, I have to remove my breakpoints. Let me continue. And now it's working. It's changing the image, but the dimensions aren't changing. Here, I mean, you don't really notice it because the presents are more or less the same size. But over here, the lights are very scrunched up. So what we need to do is we need to get these dimensions and we need to set them along with setting the image. So for that, we're actually going to use SnapKit again. So what we need to do is we need to get the dimensions for the image that the image view currently is. And then we want to update the constraints of width and height. So we'd use update constraints in this case. So first we're going to get the actual dimensions. Get dimensions, and the image view is image view. So and this get dimensions returns a CG size, which is just it has a width and a height. So we want to access by dot width and dot height. And then we want to change the image views constraints. We want to update them. And we're going to do dot width dot equal to image dimensions dot width. And then we want to do the same thing for the height. So run this. And yeah, much better. Okay, so this is working fine. This one looks just about right too. So yeah, that's the UITapGestureRecognizer. So this is implemented correctly. Now we're going to move on to move image. Now, because all the function subs have this mistake, we're going to have to change them somewhere to here. So because we're moving the image, this is dragging, or otherwise known as panning. So this is actually of type PanGestureRecognizer. So over here, I'm just going to teach you how to use documentation, because documentation helps a lot. This is the UIPinchGestureRecognizer. And okay, well, when we, okay, here, okay, good, we're here. Okay, so if you click here, these are the developer docs, and it's very useful because it tells you all of the properties that it has. Over here, we see that we can have maximum number of touches or minimum number of touches for when you're actually dragging. But what we want to refer to actually is this article right here. And this is very nice because it actually gives you examples for how to handle these gestures. So I'm just going to open the pan gestures, the pinch gestures for later, and then the long press ones because those are last. So for pan gestures, we have this little example over here that we're just going to copy and change to our needs. So over here, so let's convert this. First, let's get rid of all these comments because I'm going to explain this to you. And okay. So, all right, here are the errors. So this is a guard gesture recognizer.view, not equal to nil. This would be sender. And then this is checking, okay, guard sender.view not equal to nil. So is if the image view isn't nil, otherwise it's going to return. So instead, we're just going to use the guard that we used up here, because this is basically doing the same thing, except it stores a reference of the image view, and we're going to need that later. So I might as well put this. Let's see. The piece here that it's referring to is the image view. So we already have that reference over here. We don't need that. And then the translation, this we do. And this is the translation in piece that's super view. Okay, so this would just be the image view super view. Okay, so over here we have if gesture recognizers. Okay, that's another thing. Gesture recognizers have states. So they have, I believe, 4 states. You could have either begun the gesture. It's in, so that's began. It can be changing or dot changed, and it can also be in state dot ended. And there's also a special state dot canceled if some edge case happened. Well, we're not going to worry about that case. Over here, this is referring to some initial center. So this is actually something that we're going to have to initialize up here. So I'll just keep the code clean. That's going to be a variable. So we're going to let, it's called initial center. Okay, so initial center, and this is a, well, if I do image view, that center is a CG point, so we want this to be of type CG point. And this is a variable. So we have the variable over here. We don't have to initialize this right now. Although we do need to guarantee that we have the CG points so that we can get rid of this that error. So over here, we're setting this. We don't need the self-reference. And then this is sender again. This is the image views center. This is also the image view center. And okay, everything looks fine so far. Let's just run and see what it does. Okay, it's not moving, so we can put a breakpoint here, see if it actually does anything, and it's not, which means that it's not detecting the interaction. And the reason it's not doing that is because we forgot to actually add the gesture recognizer up here. So never want to forget to do that. So we are going to be panning for the ornament, the present, and the tree, because we want to be able to drag all of them around. So we're going to do ornament.image view. We're going to add the gesture UI gesture recognizer, target itself, and this selector is image. I'm going to copy and paste this for here, and also tree image. And we want to make sure that we actually. Okay, I did not copy this entire thing. Okay. There, that's better. Okay. So we want to make sure that we actually enable user interaction. So this is the tree image view. And we'll put the dot. And we want to make sure that we actually change these to get rid of those errors. Those will all disappear. Good. Okay. Now we can try it again. And okay, it's working. Documentation is good. Let me try dragging it again. Everything seems to be working just fine. Cool. All right. Nice. Good. All right. Then since this seems to be working just fine, we're going, oh, actually, okay, so there's an issue here. We want to put the ornaments on the tree, and we don't really care about the presents. We want to put the ornaments on the tree, and because the candy cane is appearing behind it, that's not good. So one thing I want to demonstrate here, this is another debugging feature. So if I were to put everything behind one another and I were to pause execution, I can actually click on the debug view hierarchy, and this is actually going to show you your entire app, right? And you can mess around with all of these. One nice thing about this is that I can click here, or actually, let's see. This is referring to the tree view. All right, and over here, you can see that we have the constraints. This add is these are priorities, so these are all required. So actually open a new tab with Command Tab and go back to the code. You can verify that these are right. So we have our tree. So okay, we have make.center, center X, center Y. So that's just the SnapKit syntactic trigger. And then we also have the width equal to 100, which we did set it to that. And we have the height equal to 150, which we also did set that to that. And we also have these content sizes, but this has to do with the intrinsic content size for text. We're not really focused on that right now. But as you can see, you can actually drag these around. This actually removes layers, and this will spread things out more. As you can see, the candy cane comes first, then the ornament view. This is the ornament view. Then you have your present image view, and then you have the tree. And the reason it's actually showing up like that is because if we go back to the code, that is the order that we added it to the subview. So one easy fix to this is we can just move the tree image view before the ornament image view, or because we just want the candy cane to appear on the tree, right? We're not really going to move around the code. It's just best to do view dot you want to send it back. So send subview to back, and you just do it with image view. No, I misspoke. It's not the best thing to do, but it really just depends on how you want to format your code. It's really a preference, but this should do the job right. And if we go back to the debug view, you'll see that now this is in the back, and then the ornament view is still in back of the present view because we added this to the subview first. But we don't really care about that because we don't want the ornaments to be intersecting with the presents. Okay, so I'm just gonna continue this. Okay, so it looks like the pan gesture recognizer is working fine. Now what we want to do is touch upon scale image. So over here, what we can do is Go over here. And then we have a code over here too. Okay. Yeah. So now we're gonna do this. We'll set these to sender. And this is the sender's view. And this. Okay, so oh, we got a bunch of errors. Oh, right. Okay. Yeah, we have to change this. So this is, we're pinching here. We're scaling the image. So this is just a pinch gesture recognizer. Okay, let me actually close this one. Okay. Okay, that should fix that. And close this. Okay, good. So now let's not make the same mistake. We need to add the gesture recognizers here. So we want to pinch everything. So we're gonna add those gestures over here. This is a UIPinchGestureRecognizer. This is scale image 4. So let's add the present image view. And let's do this to the true image view. Okay. Cool. All right, so we can test this now. So move this around. Let's scale it now. Okay. It looks to be working fine. Cool. We test these two. We change. Oh. Okay. So everything just got changed back. So yeah, it does look like there was a bug that we missed. So let's start this again. So that was pinching and pan. Let's just try pinching, panning things around. Let's click and everything got sent back. Now, the reason this happened is because if we go back here to swap image, right here we're updating the constraints and it's changing the width and the height. But the thing is that while we are changing the center over here for panning or the transform for the scaled image, and if we were to scale this and then click something, it still maintains its scale because the transform is completely different from the actual frame of a UI view or a UI image view. So whenever we move something around and we click, everything's going to be put back where it used to be because the constraints are associated with the frame of the object. And because we're updating the constraints over here, it's going to reset the actual constraints of the object as well. So what that means is that we're going to have to change the constraints for move image. So to do that, what we want to do is as soon as we've moved an image, ideally what happens is as soon as we stop, those should be the new constraints. So if we want to do that, we know that it stops whenever the state is ended. What we would want to do there is we just want to update the constraints. So if I were to say move this from here to here, I'd say I'd want my leading and my top trail, my top anchors to be that amount, because I already know that the width and the height should remain constant. All we're changing is the position here. So to do that, I would just do snap update constraint as before. just like here, or actually I'll just copy this because it's still image view. And here we want to change the leading, and we want to change the top. And we want to change the leading to be equal to, now here we are changing the center. So the frame of the UI image view is actually changing, but it's just the constraints that aren't changing. So if I were to actually get the frame's position and update the constraints based on that, that'd be what we want to do. So with that being said, we're going to change it to the image views.frame. Now, with the leading anchor, what we can access is actually the minimum X. And the way it works with these rectangles, if you picture this as a rectangle, or even the entire screen as a rectangle, you know that your coordinates 0, 0 would be at the upper left, which is why whenever you offset something, it's going to go down instead of up, even though it's positive, because you're starting from up there. So as you start going down, your Y starts going up, and as you start going to the right, your X is going to go up. So we want to get the minimum X and the minimum Y of the frame, and we want to set that equal to the leading and the top anchors. Or actually, wait, these are not the anchors. These are actually what we want to offset by. So we are going to do equal to the super view, and we want to offset it by the actual minimum X. So that's going to give you the coordinate of the upper left corner of that rectangle. And we want to do the same thing for the top. Okay, now I'm going to run it. Now we're going to move this around, and I'm going to let go, and unfortunately that's going to give an error. So the reason for this error is if you read here, updated constraint could not find existing matching constraint to update. And the reason for that, if we go back, I can just click here and I'll take you back. So here we're trying to update the constraints leading and top. But if we go to the constraints that we originally made, you see that the only, well, let's see, we were moving the candy cane, so that'd be the ornament image view. The only constraints that we actually made were the center X, make dot top, make dot width, make dot height. So we never actually made make dot leading. So if we're trying to update something and we never instantiated it, then in the constraints, then it's not going to work. So instead of doing update constraints, I'm just going to do remake constraints. And what that's going to do is it's going to allow us to just, it's going to be like making constraints, but we're remaking constraints. Because if you try to make constraints twice, it's going to give you another error. So because we're remaking the constraints, we want to also make sure that we remake the width and the height. And this time it's not image view dimensions, but actually we're just going to get the frame's width and the frame's height. Yeah. Click it and everything seems to be working. Now there is one subtle difference with this, and I'll make it more explicit with setting the ornament image view background color equal to red. So when we originally made the constraints, we see that we actually made its position be based on its top anchor. So when I click here, you're going to see that whenever I click right, I can consistently click here, right? Maybe if I click here, I click again, but I'm out of bounds, right? But if I click up here, you see that the width and the height are changing based on the top and also the center X. So you see it grows downward and it also grows outward because of the top and the center X. But as soon as I move this and I let go and I start clicking, you see that now it's going rightward and it's going downward because we remade the constraints and now the width and the height are based on the leading and the top anchors. So that's just something you want to be aware of. It's very subtle, but it's to give you more intuition on how we actually remade the constraints. So now that's how the constraints are actually being built. So let's remove that red color. And let's try this now. I'm going to, oh, okay, that's another bug. Let's actually see what's happening. I'm going to, okay. So if I move things around, it's fine. If I pinch, let me shrink it now. And now it's just getting smaller and smaller, which is definitely not what we want. So we know it's related to the pinching. So let's actually take a look here. We have, this is in scale, okay. So one thing to be aware of is that we are changing the transform. And as I said before, the frame and the transform are two separate things. So the issue with the transform here is as we start moving, as we start remaking the constraints every time we move, now we're making the actual constraints, the width and the height, equal to the old frame. And because we're changing that, every time we move this around, that transform scaling is being applied to the new size. If we were to like excessively make this big and were to move it, it's gonna get very, very big. So to fix this, what we can do is when we end the state, what you could do is you just want to set the sender view. You want to set it equal to the CG, not transform, or not even that. We can just do similar to here. Let's copy this. Let's just copy this entire line. So here, let's scale this by 1 and 1, see if that fixes it. Okay, fix it. Well, okay. So then if that didn't fix it, this is the right idea, but it looks like what we also have to do is we're going to do something similar over here. We're just going to capture the image view at that current state, and we're going to make sure that the transform is not left in a bad state. So let's just copy this idea over here. Or actually, we can just copy this. Okay. While we use image view, we're going to have to do, this would be better than just accessing just the optional version of image view. Okay. We don't even need a that's okay. Let's see. Cool. Same thing here. Not doing that. Let's try this. Oh, I really should have done it there too, but let's see if this works. Okay, same issue. Great. Let's just change these right here. Okay. So here we are scaling the transform. Maybe let's not scale the transform. Maybe it's scaling based on what it was before, because we do see, well, this is fine. Instead of scaling it by 1, let's try actually doing the CGFrame.transform way. And let's actually set its transform to 1, 1. So this transform, it's just a 3x3 matrix. Not very important, but you have A, B, C, D in the first 2x2, and that gives you the scaling of the. Actually, it's probably best if I show you. Here. So here what we're doing is we're changing A, B, C, D to 1. Because if you see here, the new coordinate would be based on the scaling from A, B, or C, D, and then the transform. But these transforms were used actually over here, but we're not interested in that anymore. So let's see if this fixes it. Yeah, okay. Okay, yep, that looks like it worked. Let's click. And it doesn't maintain the original scale. That's fine. The reason it's doing that is because remember that whenever we tap, we're going to get the dimensions from here, right? And these are all hard-coded. But for the most part, it looks like we click and we've panned. Everything looks to be working fine. We're going to do the same thing here. We can't click on the Christmas tree. We can click on the presents. We can also scale these. We can click. Of course, those are going to shrink, which is fine. But everything looks to be working fine. So great. Okay, almost there. All we have to do now is we need to implement copy image. So let's go over here. Okay. So the last thing we want to copy image, we're going to use a long press gesture recognizer. But one thing we want to do is, as you can see, we just keep adding these gesture recognizers specifically for ornament and present because they do the same thing. So let's just make a helper function to do that. What do we hear where our helpers are? So func, let's just call it setup gesture recognizers. And it'll take in an CG size. Okay. Oh, right, and that error is because we need to return a CG size. Oh, actually, wait, we don't need to return CG size. Yeah, I'm just copying this. Okay, yeah, so over here, all we're gonna do is we're going to copy this. And we'll also want to copy the user interactive because we want to make sure we have that. And we'll do setup gesture recognizers over here for the ornament image view. And we want to go down here and we're going to change this to the general image view. Yeah, that's about right. Cool. Okay. So get the setup gesture recognizers again. Do the same thing for the presence. Okay. Yes. Good. Okay. Let's just make sure that worked. Oops. Thank you. Okay. So great, everything's still working. Hopefully, yeah. Okay. Looks like it worked. Okay, nothing broke yet. Great. Great. Okay, so now what we want to do is set up the pinch gesture recognizer. Now on the slides, I did instantiate it like this. Long press gesture recognizer, and we're just going to do this just so that you can see an example for one, because for the other ones I would just directly put it in the parentheses. You don't necessarily have to do this. I just did that because we weren't setting them up, but we're going to set this one up. So this would be a long press gesture recognizer, and we're going to modify one of its properties. I think it's called minimum press duration. Yeah, and here the long press gesture recognizer's minimum press duration by default is 0.5 seconds. So I'm just gonna set it to 1 second because I want to make sure I'm actually holding it down for a long enough time to notion that I want to actually copy one of the images. And with that, I'm going to add that gesture recognizer. Great. Okay. So I did forget to do this, right? Yeah, that has to go in there. This is copy image. Great. Okay, so that looks fine. Uh-oh, I think there's an extra parentheses. Yep, there. Okay, good. All right, so I'm gonna pause here real quick. Where's the pause button? Okay, so I'm back. So now we're gonna implement the copy image. To do that, what we want to do is we just want to make a copy of an image view. So we need access to the image view of the sender first. So once again, we're going to copy this. Okay. And now to make a copy of the image view, let's just make a image view. Now I don't want to make what's wrong here? Once again. Okay. Long press, right? So long press. Okay. So I don't want to set new image view equal to image view because I want to make a copy of an image view. I don't want to make a reference to it because then that's not what we're trying to do. And okay, that's fine. We're going to use it soon enough. Okay, so to make a copy of the image view, if we see here, the way we're doing that is, oh, I did forget to mention one thing. Because we're using SnapKit now, we do not need these pesky lines of code. These are only necessary using NSLayout. So I'm sure you've had the issue where your constraints aren't your views aren't showing because you have that line. But with SnapKit, you don't have to worry about it. So that's great. Now back to this. Looks like for our image views, we actually instantiated, which we did down there. We need to set the image equal to something, and then we want to set up the gesture recognizer. So let's just copy this down here. We want to set the, actually the new image views image equal to some certain image. Now because we're copying it, let's set it equal to this image. Because when we're long pressing, sender.view is, say, if I were to open the app, if I long press this Candy King image view will be this. So when I'm making a new image view, I want to make sure that the new image view has the image of the image view I was long pressing. So I also want to set up the gesture recognizers. And let's add this as a subview. Now, next thing is I want to make the constraints. Now I'm going to copy this. Let's just get the exact position of the image view that we're long pressing. I realize that this should be the new image view because we're changing the constraints of it. And we're not remaking the constraints. We're making them for the first time. So we want to make sure that's make constraints. So this looks fine. Let's run this. Okay. Let me hold and, oh, actually, that's another thing. Let's actually add a print statement here. New, so that we can actually see what's going on. Okay, let's bring this up. I'm going to hold, great, and I let go, and it looks like 2 were added. I were to click and then drag. Now we have more candy canes than Santa wants to eat. So the reason this happened is because realize when we're long pressing, as soon as that press activates, we're going to enter the began state. As I was dragging while still long pressing, it was in the change state. And as soon as I let go, I was in the ended state, which is why when I initially held the button, it's a new image added. As soon as I let go, another image was added. So we want to make sure that we only copy the image once. This is why we want to make a single copy of the sender. And to do that, I can just put it here in the guardlet. Let's just make sure that the sender state is actually began. Otherwise, we're not going to enter this function or pass the guardlet because it does enter the function. So let's hold again and let go. Looks like it worked. Great. So looks like I can mess around. Let's do this. Okay. And I just clicked here and it disappeared. If I click here, this is working. And that also disappeared, which is not what we wanted. No, this is weird. I am expecting some print statements to be running. Let's just debug on the fly. That was not on the script. Okay, here we go. So I'm gonna click step and let's try that one more time. Run this, click again, step in, and nothing's actually happening. Let's see, the image dimensions. Oh, this is for this. This is a little bit weird. I do not understand why this is happening. It should be. Oh, actually, here we go. Let's try one more thing. Before we break, okay, let's make a copy. Great, let's try swapping and step. Great, okay, so yeah, I guess the reason it wasn't actually entering the switch statement is because it would just go to this break. But what's happening is we're entering the default case, and the reason for that is, as I put in this print statement, the new image view that we made is neither the ornament image view or the present image view. So the way we currently have things implemented is not ideal because we don't want to base it off of the image views. We want to know whether or not we're switching on some kind of ornament image view or some kind of present image view. And there's multiple ways of going about this. One way we can do it is similar to one of the challenge problems in project 3, your square and circle arenas, where you can just have a list running and then you can check based on there. Or a much simpler approach would be is if we actually set the tags of these image views. And we can do that by go here. So a tag is just like an identifier for any kind of view really. And the default tag is 0, right? So we're going to say that ornament tags are equal to 1, or ornament image views have a tag equal to 1, and that present image views have a tag equal to 2. And I can do that here, make it look much better and more readable by making a enum. We'll call it ornaments and presents are decorations. And well, this is actually not advantage. It's going to be a type int because that's the tag type. And let's see, we're going to call one of them ornament equal to 1, or ornament is 1 and present is 2. Okay, maybe I'll just do this. I'm going to look up swift syntax. Okay, so I did forget the case keyword, and we can look for example here and set it equal to. Okay. There's no shame at all to look at syntax. It's perfectly fine. So here we go. And I think that looks like, okay, now we need to set this to and yes, okay. It looks like this. Good. Okay. So we need to make sure that we set these tags too. Let's set the ornament image view tag equal to decorations dot ornament. We want to get the raw value of it, so it's just going to be one. Very fancy, but much more readable than just a one. What does one mean? Here we will set the tag equal to present. Good. And let's go over here. Want to do the same thing for the tag here. Okay, so here, once again, the image view should now have a tag because we set them. So we're just going to set it equal to the same tag. And that should be fine. Now, the only thing that we have to do now is we want to switch or swap and get dimensions. We want to switch not on the image view, but its tag instead now. And that's what makes this approach much nicer because there's not much to change now. So the cases should be, this would be the ornament dot raw value. Decorations. Present dot raw value. This is raw value. Okay. Okay. Do the same thing down here. This is good. Okay. Oh, okay, good. So let's rerun one more time, see if this works. Okay. Everything still works as expected. This is working, so let's copy this. New image added. And yes, we can tap both of them. Okay, great. So it looks like we have a function up. Let's just decorate this a little bit. Okay, we have 2 copies of these. Let's put these lights here, shrink them a little bit. Okay, good enough. The GG top. So it's just 2 in smaller. Okay. And then we'll do the same with the presents. Great. One observation is this is actually the last present that I instantiated, and once again, because I'm making those constraints, you can tell which one is the original, which is a copy, because this is the one at the very back, and these could have only been created had I made a copy of this. So we can just shrink this one. Actually, you have to get both fingers here. In fact, I did forget to mention how to actually activate this. So you want to press Option on your keyboard, and then you can just move it around, and it'll be centered. What you want to do to actually move it across your screen is you'll also want to hold Shift, and then you'll move it in that trajectory. So this is without Shift, and this is with Shift on. Without Shift and with Shift on. And if I were to click here, we can actually see everything on the app. We can spread everything out, and we can see more or less when everything was added. We can decrease this. We'll see what was added when. But this is how you use this, and yeah, that's pretty much it. So yeah, now you have a nice little game, and there are other gesture recognizers that you can learn how to use. Once again, remember that there are lots of articles here, lots of examples already on the documentation that, as you can see, I just copy pasted and I switched some variable names and it worked pretty much. Just some issues because when you combine gesture recognizers together, it tends to be issues, especially with the pinch. You always want to be careful with uh, leaving the transform without you want to be careful if you don't set it back because then you get weird bugs like that. Transform and frame are separate. And yeah, that's pretty much it. Feel free to incorporate this into your hack challenge. This would be very nice to see. So we'll just go back to the keynote. And last thing on the agenda is just the action items. If you haven't already, make sure to join the Discord. That's where all communications are going to be taking place. The last day for idea formations is tomorrow at 11:59. So make sure that after that, you want to get a head start on your projects. Everyone's going to receive an iOS mentor, and you can just communicate with them on Discord. And your midpoint submission is on Tuesday of next week. And the minimum requirements are having one collection view or a table view, and you can just hard code the data for now. Eventually, you can integrate with backend, and you also want to have one kind of navigation interaction. So yeah, thanks for watching and good luck on your hack challenges. We are very excited to see them.